Movement of electrons. Let us see what will happen and how to show the movement of electron in these cases. Suppose we have a single bond, sigma bond, between a CH3, SCH. So let us imagine what is the actual picture. The actual picture is CH, H, H. This is the CH3. Then a single bond S. Then यहाँ पे C, H, H. Correct? Suppose this breaks like this. Naturally, it will break like this. Why will it break like this? Because S is more electronegative than carbon. So the bond breaking is shown like this. You are asked what will be formed. I will get a CH3 with a plus because electron which was bonded here has been removed from this carbon. And I will get SCH3 minus. This is a cation. This is a cation and this is an anion. Now, why did I put a positive charge here? Because the bonds were shared by both the atoms. Now they have been snatched away from this carbon and given all here. This was having only one electron. Let me show a bond like this. If a bond is shown like this, having only one electron now has two electrons. So it develops a negative charge and this has become electron deficient. What is formed is a cation and an anion. And this specific cation with carbon with a positive charge is called carbocation. Let us see the second case. You are supposed to know where will the atom bond move. Look at this. You could have also shown like this. The products would have been same. Look at this. Here, the electron pair, accordingly, if I see, look at the picture. C, H, 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 C, triple bond N. Now, if I see these two carbons, the bond will not move anywhere. If I go to the second atoms attached to them, this atom is attached to hydrogen. This is attached to nitrogen with the multiple bond. Very electronegative. So the bond will definitely break like this. More electronegative atom. First atom doesn't help you decide. Go to the second atom. Now I move it like this. So what will I get? I will again get a carbocation and an anion, Cn with a negative charge. Let us see the third case, this case. Here, copper is there. So what is the picture? Let me again see it. See, there will no bond plus a minus. If I imagine plus minus को cancel करके I can make bond, the bond will be so weak. Metals don't accept electrons. So the electron pair will move towards carbon. I will have to put it like this. See the periodic table. The metals come before the non-metal. Copper is here and carbon is here. In the periodic table, copper is here and carbon is here. So carbon is more electronegative. Bond moves towards carbon. Here I get carbanion. Children, this is also a carbanion. This is a cation, anion. This is a cation. So it can be, I can get in the same reaction a carbocation and a carbanion. It can happen. I can also get only one of them. Now this is the another case. Suppose this is an atom Y and you are shown like this. What will happen? What will be the next picture? It is having two bonds this side, one bond this side, and a bond is shifting. Pi bond is shifting. So what will happen is, यहाँ एक ही bond and यहाँ पे two bonds. But if this double bond is shown like this, यहाँ तो it has been shown it is moving here. Suppose it has shown like this, then what will happen? I will get this and this. And if these electrons again fall back here, stages में आता है, पहले इधर, then इधर, तो मुझे क्या मिलेगा? ये मिलेगा. So I should know where should I direct my bonds. In which direction and till where? Where do they start? Remember, only electrons can move. Positive charge never moves. And electrons are of the bond are tightly held. So if an atom has loose electrons, the loose electron will move. If it has pi electrons, pi bond, the pi electron will move. But never show it the reverse way, the positive charge moving. Positive charge is a deficiency. It looks like it is moving, but no. Only a particle can move. And the particle is electron. The movement is always electron. Reagents used in organic chemistry are of two types, nucleophile and electrophile. What is a reagent? When an organic molecule, it is a substrate, it is attacked by a molecule smaller in size, by having a charge, then the molecule which is attacking it is called a reagent. And the organic molecule is called a substrate. So now, the reagents are of two types, nucleophile and electrophile. The word philic means attracted. So a nucleophile is the one which is attracted towards nucleus. A nucleus is positively charged. So whenever a nucleophile has a negative charge or it is electron rich, neutral molecule or an anion, it will be attracted towards nucleus having a positive charge or any positive center, and such a reagent is called a nucleophile. So what is a nucleophile? It is an electron rich species or a neutral molecule having lone pair of electron which is attracted towards a positive center. What is an electrophile? It is denoted by writing E+. Nucleophile is Nu minus or Nu, these two dots are lone pair of electron. Electrophile is an electron deficient species. Deficiency means less, lack of it. They are generally 6 electron or they have a positive charge. जैसे कि the molecule BCl3. This is a 6 electron, 3 chlorine giving 3 electrons, boron having 3 electrons. Then BeH2, this is a 4 electron species. So they are AlCl3. They are electron deficient molecules, neutral but electron deficient. 13th group elements. Look, aluminium, beryllium तो second group है. Boron, ये 13th group के. Then positively charged, a carbocation with a positive charge. It can also be NO2 plus. It can also be a carbonyl group. Oxygen is pulling away electron from this carbon in this direction, more electronegative. So naturally a partial positive charge is here and a partial negative charge is here. So all of them will act as a electrophile. Next topic.